Watch as this assembly line pumps out tiny machines called micromotors. These micromotors are only a few hundred micrometers long, and they can move when put inside a magnetic field. Scientists propose that micromotors like these could one day deliver drugs inside the body, or clean up wastewater by absorbing pollutants. Micromotors can propel themselves in a number of ways. A popular way to get around is to use a chemical fuel, such as hydrogen peroxide. Materials in the micromotors react with the fuel to produce jets of gas bubbles that push the tiny particles forward. But this approach can introduce toxic compounds into the motor's surroundings. Ditching the fuel and just using an external magnetic field to move the motors avoids these toxicity issues. It's a strategy that's also well suited for biomedical applications because magnetic fields can penetrate the body. Now, a team of researchers at the Chinese University of Hong Kong and Huaqiang University of Science and Technology have developed novel magnetic responsive micromotors made of graphene. Researchers can easily attach other molecules to graphene, and the material has a high surface area which makes it attractive for picking up pollutants. The corkscrew shape helps micromotors move in a rotating magnetic field, but it's been challenging to make helical micromotors from graphene until now. To make the micromotors, the team developed a cheap microfluidic method. The team pumps oil through a solution of graphene oxide and magnetic iron oxide, and a solution of sodium alginate. What comes out are tiny corkscrews with an oil droplet head attached to a graphene oxide-based tail, all of which are sealed inside a sodium alginate fiber. The helical motors get their signature shape through the liquid rope coil effect. This effect depends on precisely controlling the flow speed of each fluid. For instance, if the oil is injected slowly, the material comes out fairly straight, but as you increase the oil speed, you'll see the material start to form coils. The team takes the coils they made and reduces the graphene oxide to graphene, then washes away the oil and sodium alginate to isolate individual graphene micromotors. By applying a magnetic field, the researchers could navigate the micromotors through a microfluidic channel, and they found that motors that have smaller diameters and more space between their coils moved best. The team also attached silver to the micromotors to investigate their ability to kill bacteria. The silver micromotors could kill E. coli in a petri dish, most effectively when they were moved around by a magnetic field. While micromotors haven't appeared in real-world applications yet, many devices, like this one, are moving forward.